In this video, we're going to review how to submit jobs to the LSF scheduler. It works the same on Triton and Pegasus, and we're just going to display a serial job in this video. We'll go over parallel and interactive jobs in the future. So when you log into Pegasus and you want to process your data and your program, you can't do that on the login node because the login node has limited resources. Login node is the node that you reside in once you SSH into the cluster when you sign in. Okay. We use something called an LSF scheduler. So you submit your job in the form of a job script to the scheduler. The scheduler, its task is to search through the worker nodes or the compute nodes and find a node with resources best suited to work on your job. And then that node processes your data and your program and everything like that. So I'm going to just take you through a very easy step-by-step process on the things you need and how to accomplish this. So right now I'm logged in on Pegasus, and I'm going to navigate to my Scratch path for my project. It's HPC. So the specific example I have is in a different folder. Let me just navigate to that. Okay. And when you launch jobs to the LSF scheduler, when you run your programs, you always want to do it from your Scratch folder. It's just better optimized. You don't want to do it in your home directory. So as you can see here in my Scratch folder, I have a few files. We have a Python program, we have some data, and then we have a LSF job script. So the LSF job script, this is responsible for defining the resources that you're requesting for your job. So let's go ahead and take a look at what that job script looks like. So every job script is essentially going to more or less look the same. At the top of the script here, you have these B-sub options. These are just the resources and the parameters of your job. So you define the parameters of your job script, and then at the bottom, you execute your code. That's just the basic formula. Let me go over some of these options with you. So B-sub-J is the name of your job. -P is your project ID, very important because you have to submit your job with a project ID or your job will not submit. -O and -E is the output and error log files for your job. This %J is just an environment variable. This will assign the job IDs to the .out file. -W, capital W, is the wall time for your job. So this means that this job will run up to an hour and then it'll be killed. If it finishes earlier, that's great. It finishes earlier. But this is just the time that the job will run until it's terminated. Q is the queue that the job will be submitted to. In this case, it's normal. I'll go over what queues mean later in a separate video, but essentially what you need to know is that the worker nodes, the compute nodes, are separated into different queues depending on their purpose. So the normal queue is just for any normal job that you might want to send, like a Python program to process or something like that. If I wanted a job and I need a lot of memory, I would send it to a different queue. -N is the number of cores assigned to your job. In this case, we're just assigning one core because it's a serial job. If this is a parallel job, we would be assigning multiple cores. And then capital R usage mem, is the amount of RAM I'm assigning to my job per node. So this right here is 2,500 megabytes or 2.5 gigs. So the way this reads, and this is very important, is I'm assigning 2.5 gigabytes per core. So I'm using one core, right? Let's say I had N was 2. Then I would be assigning 2.5 gigabytes per core. And there's 2 cores, I'd be using 5 gigabytes in total for the job. This job, I'm just using 2.5. So those are the parameters. At the bottom here, I'm loading the Python module, and then I'm executing a Python program, and then I'm redirecting it to like an output text file, the results. Okay? And you don't have to worry about memorizing all of these parameters. It's all defined very well in the documentation, which I'll show you afterwards. All right, so let's just take a look at these other files that you have. So you have a job script. You need your Python program that executes the data. This is a very basic Python program. All I'm doing is opening that CSV file and reading the first 10 rows and printing them. It's just a very basic thing just to show you how a job runs. And then I have just this data, just dummy data. Okay? So now that I have all the pieces, I want to submit my job to the LSF scheduler. The way we do that is with the bsub command. Bsub, then greater than sign, and test job. Your job script. You're gonna hit enter. Just hitting bjobs really quick. So you have some output here. You'll see job is submitted to, and then your project, and then you'll be assigned a job ID. This is very important to keep a note in case something goes wrong with your job. You want to keep this job ID. You can send it in a email for help to Advanced Computing Group, and we can take a look at your job statistics with this job ID, and then the queue that the job was submitted to. Here you saw me run a command called bjobs. Bjobs, what that does is it gives you the status of your pending or running job. So at the time when I typed in this command, it shows that my job right now is pending. It's probably done by now, that's why I typed it so quick, because this job is going to finish very fast. But you'll see your job ID, your user, who submitted it, the queue is submitted to, from where, login 1. This is the login node. Here you would see the execution host, like if it was assigned to N081 or something like that. This is the worker node. It's empty right now because at the time I typed in bjobs, this was still pending to be submitted. The name of the job and the time you submitted. If I type in bjobs again right now, it'll say no unfinished job because the job is done. Okay, so let's type in ls. Let's see the contents of our directory. And you see I have quite a few output here, and we'll go over each of them. Yeah, so you'll notice that when you submit a job to the LSF scheduler, it gets kind of sent in the background, and you don't really interact with it. It works in the background, and then you just have to wait until your job is finished, until it executes all your code, right? So it spit out a few things. This is that .er and .out I was talking about in the job scripts. You see the job ID .er .out. So if anything went wrong with your job, this is a good place to take a look at what happened, that .er file. Let's open it up. Hopefully nothing went wrong. It's empty, which is always good. That means nothing went wrong. Okay, now let's look at the .out file. This will give you a summary of the node that worked on your job, what your job looked like, the memory. So let's take a look at what this looks like. We have a job ID up here, who submitted it. This is the job was executed on host N036. This is one of those worker nodes I was talking to you about. So N036, that machine worked on my job. And it also tells you like where the job was submitted from. You see it was submitted from scratch. It'll give you a summary of what your job script looked like, and also a resource usage support. So this is the memory usage for your job. This is also pretty useful. So one good thing to note is some of these metrics here. The total requested memory. So I asked for 2.5 gigabytes, right? The average memory, it only used 11 megabytes, max 11 megabytes. Delta memory is 2,480 megabytes. Yeah. So really cool thing to know about delta memory is that if that's ever a negative value, that's an indication that you might not have, you did not request enough memory for your job. So you don't want this to be like a negative value, okay? So I'm going to go ahead and exit out. Then I got output.txt, which is just my test job where I redirected the output. And you can see I'm just reading the first 10 rows of that file, of that CSV file. So essentially, yeah, that's how you run jobs on the LSF scheduler. Another useful command is if you want to see the history of your finished jobs. So this only works with finished jobs. You can use the bhist command followed by -L and then your job ID of your finished job. So right now this was 165.356. Give it a second and it will output all that information. So here it gives you, your job ID, kind of like your job script here, where it was submitted from. It was dispatched one task, which means, one core, on N036, and then the amount of memory it used, the PID, if it was successful. So this is just, how long it ran, the max memory, average memory. So if you wanted to get like just a very quick summary in terms of memory and what was used for your job, you can use the bhist command here. Let's see. Oh, another good lmod. We'll call them lmod commands. Another good, or no, that's not right. We'll just call them job commands. Another good job command to note is bhost. Let me clear the screen really quick because it's a little cluttered. Bhost. So what this does, bhost, is it will display all of the compute nodes or the worker nodes available on the cluster right now. The one that worked on my job was this one, N36, I think. So this will give you a good idea of what's available on the cluster right now and what's being used. So for example, N27, look, this is closed. Each of these nodes, by the way, has 16 cores. So you can see this one, 16 out of 16 are being used right now. So no jobs can be sent to this. 3 out of 16 are being used for N30. So, there's probably some space on N30. Though the LSF scheduler's job is to find in this list which compute node is best suited to work for your job, work on your job. You can also see a list of queues that we have available with PQs, and that will give you just right now we used the normal queue, for example. So these are just some helpful commands to navigate the LSF scheduler. I'll go ahead and show you that documentation now. Go here, open this up. They're very much similar between Pegasus and Triton. Let me just open here Pegasus job scheduling and LSF jobs. LSF commands, that's what I meant, not lmod commands, LSF commands. So here you have like an example job script and what each detail looks like. One thing that I didn't put on my job was a combination of these three commands, BNU, and then an email. So if you input those, it'll essentially email you the status of your job, like, oh, your job was submitted, or oh, your job has just finished. It'll give you all those reports, okay? So you have an example here of a serial job, and you have an example of parallel jobs. This page has a lot of examples, and I'll provide it in the description as well.